Hey, John here. Today we're going to be talking about the scientific method and hypotheses. Let's get started. The scientific method is a process used by people in everyday lives, whether they realize it or not. Scientists use it to produce reliable results to answer a specific question. There are a few steps that make up the scientific method: a question, a hypothesis or hypotheses, an experiment, an observation, an analysis, and a conclusion. There's no set order you have to do these steps. Sometimes you'll just have a question that starts it all. Sometimes your question is based off of something you observed. Many times you'll repeat steps too. Either way, do not feel like you have to follow a set order. I would say that this is an order you can feel confident about following until you feel more comfortable with the scientific method. Let's look at each step individually. A question. It seems pretty simple. That's because it is. Have you ever just wondered why something is or why something happens? That's a natural phenomenon and a natural scientist inside you. A question is simply when a scientist proposes a problem they want to be solved. Once that question has formed in your mind, it's only natural to start coming up with possible answers, which leads us into hypothesis. Hypothesis is an informed guess as to the possible answer to the question. It can also be viewed as a prediction. The hypothesis may be formed as soon as the question is posed, or may require a great deal of background research and inquiry. The purpose of the hypothesis is not to arrive at the perfect answer to the question, but to provide a direction to further scientific investigation. This leads into an experiment, but we will come back to how to create a hypothesis in a little bit. An experiment, or test even, is an ordered investigation that is intended to prove or disprove a hypothesis. It must be controlled, as in it must test a single variable by keeping all other variables under control. The experiment must be reproducible so that it can be tested for errors. During the experiment, you'll begin to observe changes, or the lack thereof. An observation is the knowledge gained through the senses, or through the use of equipment. Also, during the experiment it is important to note down the results. In any experiment, it is necessary to conduct several trials to ensure that the results are constant. Analysis is basically comparing the results of the experiment to the prediction posted by hypothesis. The experimenter then analyzes all the data and uses it to draw a conclusion regarding the strength of the hypothesis. A conclusion is a statement whether the original hypothesis was supported or rejected by the observation as gathered. The original hypothesis in the conclusion is based off of the null hypothesis. If you support the hypothesis, you would say, I fail to reject the null hypothesis, rather than saying or using the verbiage support. Since we're mentioning the null hypothesis already, let's go back on what the different hypotheses are and how to write them. Just a reminder, a hypothesis is an educated prediction that provides an explanation for an observed event. This observed event must be measurable. There are 3 different types of hypotheses to help organize and clearly specify what you are thinking. They are biological, which is based on biological mechanism; null, which enables you to test something statistically. It is usually started in some way like, there is no change, or there is no difference. That is the hypothesis you are basing your conclusion on. And alternative, which is usually the opposite of the null. So there is a change, or there is a difference. Usually a hypothesis is an if-then statement. Think about how your independent variables will affect your dependent variable. This is assuming and predicting that your independent variable is the cause of your dependent variable. Let's do an example. So let's start with a question based on a biological mechanism. Since I'm a runner, let's ask the question, how does sleep affect the performance of a collegiate runner? There are two variables here we can pull from this to work with. The independent variable being the number of hours of sleep a runner receives, and the dependent variable, which is the times the runner races in. From this, we can create a biological hypothesis. If sleep enhances the performance of a collegiate runner, then receiving 7 to 8 hours of sleep each night will continually improve the performance time of a collegiate runner. The null hypothesis we can create for this is there is no improvement of time in a runner's performance when they balance the number of hours they sleep. The alternative hypothesis would be there is an improvement of time in a runner's performance when they balance the number of hours they sleep. These are one-sided hypotheses. A more general null hypothesis could say there is no difference in time rather than there will be an improvement. From here we can now create a controlled experiment. I think I'm just going to jump right in and go to sleep. Thanks for watching.